Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great event on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to listen to it later on demand. We will be sending out an email that contains a link following today's webinar, and the link will take you right to the webinar on demand. And we are taking questions from the audience, so if at any time during today's presentation you have a question for our panelists, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions, and we'll get to as many as we can near the end of today's webinar. Also today, near the end of the webinar, we are doing two separate drawings. One is for 3 winners of a $50 Amazon gift card, and another is for 3 winners to a copy of an ebook that is going to be discussed during today's webinar, the Engineering the Digital Transformation ebook that was written by Gary Gruver, who was one of our speakers today. So stick around for both of those. Hopefully you'll be one of our 6 lucky winners today. All right, with that, we're gonna go ahead and kick off today's webinar, which is Architectural Principles of Digital Transformation, a discussion with Gary Gruver. Our speakers today are Gary Gruver, who is president of Gruver Consulting, and Jeff Keyes, who is product manager or director of product marketing, I should say, at Plutora. Welcome, guys. Thanks for joining me today.
Thank you. Glad to be here.
Awesome.
Yeah, thanks for having us.
All right, great. Well, Gary, I'm going to go ahead and put myself on mute and let you get right down to it.
That's fantastic. This is Jeff from Plutora. I wanted to give a bit of, everybody knows who Gary is because you know, Gary, you've been out in the industry for a long time promoting these things. You might wonder, why is Plutora here with Gary Gruver, and what does this actually mean? I love the new book that you've got out. I know you're going to talk about that. The methods and techniques and practices and direction are exactly what companies need to do. And the reason why Plutora is here is because if you follow these methods, you're going to need tooling like Plutora to help you in that journey. So with that, you know, Gary, take us away, because I'm really excited about what you're going to talk about, because this is, I think, one of the Achilles heel of people who go down the path of trying to transform their business, and they run into architectural problems.
Great, thanks, Jeff. Do you believe the effectiveness with which your organizations develops and delivers software is important to how you compete in your industries? Do you think there are opportunities for you to improve how you develop and deliver that software to make you more efficient? But do you struggle to get your organizations aligned to commit the resources to make the required changes and implement the improvements over time and follow through? If you answered yes to those 3 questions, you're like a lot of the clients I work with out in the industry. They know this stuff matters. They know it's important. They know they can get better, but somehow they just can't sort of engage, follow through, and create the momentum that they need for a successful transformation. If anybody knows me very well and has heard me speak or spent time in the industry, ever since I finished this large-scale transformation at HP, where we were able to deliver a 2 to 3x improvement in productivity, I've been very passionate about trying to figure out how to help other people realize those types of benefits, because it was such a transformation for our business, our employees, and for myself. I spend a lot of times doing webinars like this, trying to help people understand how to approach a successful transformation and how to avoid mistakes that I've made in the past. I do workshops within companies where I not only just sort of talk about these ideas, but I help coach them along their journey for a couple of reasons. One is people are more ready when they run into the problems to listen to the types of things I'm saying. And the other is it gives me an opportunity to really see what's working and what's not working, and the types of things where they're really seeing the benefits and improvements. And I write books. I've written a practical approach to large-scale agile development, leading the transformations, starting and scaling DevOps in enterprise. And I swore to myself I was never going to write another book again, because it's a lot of work, It's a major pain in the rear, and there really aren't that many benefits that come back to the authors in terms of writing the book. So I swore I was never going to do it. But last fall, I was watching several of my clients struggle to make progress as fast as I really felt like they should. And I really did a lot of deep soul searching. I figured, there's got to be a better way. We got to get better. And I grew up in a manufacturing environment as a process engineer, and there are very systematic approaches for how you improved, how you do manufacturing, and how you get better. And I figured there had to be something there that we could learn from. I did a marketing tour through Europe and argued with a bunch of different people in cities about how to do it and different approaches. And it really reinforced me that, we can't just implement the latest Agiles and DevOps practices and hope our business gets better. We need a systematic approach for doing this. And I went to DevOps Enterprise Summit and I started talking to a bunch of different people about, my history in manufacturing, what was there. And a lot of the responses I got was, yeah, we just need to do what manufacturing did and learn from that. And as somebody who grew up in manufacturing and had spent over a decade in software, what I realized is that doesn't work. Software is a very different beast. There's a lot we can learn from manufacturing because they've been tried and true practices that have worked over multiple decades, fine-tuned and refined, but we can't just apply those principles directly to software because software is a very different beast. It has a lot of unique characteristics and capabilities, and we need to take those into account if we're going to get the types of improvements that we need to. My latest book in that I've got out, Engineering the Digital Transformation, is really about taking some of that engineering rigor that was in manufacturing and applying it to software and modifying it with approaches that will work for that. This is the second webinar in the series. If you haven't seen the first webinar in the series, it provides an overview of that systematic approach. That's out on DevOps.com, and I'm sure Plutura's got a copy and they can help you get access to that one. This is the second webinar where we're really going to go down into the architectural approaches, because what you find in manufacturing, and I believe it's true for software, is the application defines the practices. If you look at what was done in manufacturing, Henry Ford really focused on minimizing quality issues and minimizing inventory in the system and maximizing flow of value through his organization by having a linked assembly line with minimal inventory. And he could go from iron ore on one side of the factory to a finished car on the other side of the factory in 81 hours. And that worked really well when he was delivering the car in one place, and you could get it in any color you wanted as long as it was black. And he used those practices to do that. Now, when you went into different applications over time and you had multiple machines developing and delivering a lot of different products, that approach didn't work. And so to minimize inventory and to maximize flow through the organizations, Goldratt came up with the theory of constraint approaches, where he understood the constraint in the process and he used his drum buffer rope to maximize flow and minimize inventory. He modified his approaches to address the problem that he was trying to solve. Ono at Toyota took that one step farther with Kanban, and he really maximized it he was trying to compete with giant US manufacturers when Toyota was very small, developing a wide variety of product. And for him to maximize it, he really focused in on the Kanban process, which was controlling inventory and flow through all the different steps in his manufacturing process. And that enabled Toyota to be competitive. And the key learning that we have from manufacturing is the type of application you have and the problem that you're trying to solve really drives the practices. You can have a common set of principles, but the practices need to be fine-tuned to address the problem that you're trying to solve. In manufacturing, they typically start with the design of a product. The product will look like this. They will have the design of all the assemblies, all the parts that need to go together. They may have customizations that they do in different regions. And manufacturing is focused on DFX, where the X stands for design for manufacturing. It can be designed for quality. It can be designed for supply chain. And manufacturing is really focused on the design of the product, has broad implications on how value flows through the organization. And once they have the product design, then they go over here and they focus in on how do they manufacture it, how do they distribute it. They take all their different sub-assemblies, they figure out how they're going to be built, they put together into a factory, usually in a low-cost regions. If they have customizations, they try to do those as close to the customer as they can so that the response time's low. If they don't have customizations, they try to centralize that manufacturing, because if you get closer to the individual stores, the demand variability is higher, and you want to try to localize that to a common node to where there's less demand variability. And when we think about this for software, our product design is really our architecture. It is all the different pieces and parts that have to be assembled and put together to deliver value to the customer. And our manufacturing supply chain is our deployment pipeline. This is how code gets checked in. This is how it gets deployed. These are all the steps that it goes through in terms of getting to production. And how we design our product and our architecture has broad implications on how it flows through the system, and the application has implications. I feel very strongly, after having worked with a lot of different organizations, that the first step in thinking about how to improve things is really understanding the problem that we're trying to address and understanding the specific application. And then and only then can we take that next step. And for me, the very first step is trying to make sure that this product and our deployment pipeline are very visible within organizations. And there's different types of architectures, or different types of challenges, and there's different types of things that you do to improve those different applications. Probably the most straightforward that everybody's heard a lot about in the DevOps community is loosely coupled deployment pipelines. These are the types of applications that Netflix or Amazon has with their 2 pizza teams, where small groups of people can independently develop, qualify, and deploy code. The developers can work on a new capability, a new feature, they can run it through a test environment and deliver it straight into production using a canary release or A/B testing to get them very quick feedback on these types of things. These are the types of things that you frequently hear talked about at DevOps conferences. These are the different approaches. I've had this ongoing debate with Gene and Jez for, I don't know, probably going on a decade, that, you know, a lot of the types of things I hear them talking about really feel like they apply to these loosely coupled teams. And if you have a more tightly coupled architecture, you need to be taking a different approach. Finally, after arguing about this for several years, in 2017, with the DORA report, they went and tested for architecture. They asked the questions about, can your team independently, small team independently develop, qualify, and deploy code? And what they found came back is it was one of the strongest correlations from the DORA report for success in DevOps is having a loosely coupled architecture, which makes a lot of sense to me. You're going to be able to deploy more frequently. You're going to be able to respond and react more quickly if you've got an architecture that doesn't require coordination across a large number of people. So I finally came to the conclusions, great, we've tested that, we know that that's important. Now we can start coming up with different solutions for the tightly coupled teams, to which the response was back, no, Jez would just say, no, it's so important, we need to help all these organizations understand that they just need to re-architect their applications and go to loosely coupled. And to me, that was a hard pill to swallow a little bit, because I'd led a large scale transformation. It took 3 years to rewrite 10 million lines of code at HP, and it was one of the most difficult, painful, and hard things I'd ever done. And I don't think it's the first thing that you can be doing to improve the efficiencies. And if you can re-architect, great. I think it's a good step. It's the right step in the right direction, but I do think there's other things that you can be doing. But if you've got a loosely coupled deployment pipeline, the types of things you're going to do to improve are really, in most cases, removing a lot of bureaucracy that sits in these organizations and empowering these teams to learn and adjust. It's going to be putting in capabilities for A/B testing and canary releases. It's going to be getting rid of your change advisory boards that slow things down, and having a complete complete team that can own all the solutions. So these are a lot of the things that you hear about at DevOps conferences and working. And if you can get to a loosely coupled architecture, it's validated with scientific researches. This is the most efficient way to work, and you can get there. What I find in organizations is that there's not that many large organizations that have re-architected to have loosely coupled, and most of them tend to run with these larger tightly coupled architectures. Example like this, and ideally for these you would do things very similar to what you would do with the small teams, which is you want to build and deploy and test on a more frequent basis to enable you to efficiently triage. The challenge is it's hard to build a lot of these large applications and test them on a frequent enough basis to get it to where there's a small enough number of commits in each build test cycle that it's easy to do triage. In these situations, what you typically need to do is break the large system down into smaller subsystems using service virtualization that enables you to test each of the subsystems differently, and then you can create some subsystems. What happens in these organizations is then you end up with a deployment pipeline that looks more like this. You're building up each application on a more frequent basis. You're building up each subsystem on a more frequent basis. You're moving them into a QA environment. You're moving them into UAT, staging, and then production. And this is a bigger, larger, complex system than you have with the loosely coupled. And we need to think about how do we optimize flow? How do we improve the process with this situation? What we find in a lot of organizations that we go into is the time that it takes from an engineer checking in code till when it's ready in production is much longer in these large, tightly coupled systems. And we can't do deployments daily or weekly. Are some of the challenges that we have here, even multiple times a day. What we tend to do is we see these organizations, because of the length of time here is longer than the customers see, than the customers are willing to wait or the business is willing to wait. Organizations tend to solve that problem, not by necessarily optimizing the flow through here, but they tend to figure out how to release more frequently by creating multiple release branches. In this case, if it takes them 3 months to get through their deployment pipeline, but they need to release on a monthly basis, they'll end up creating 3 different release branches. And essentially what you're doing here is you're just duplicating your entire manufacturing process for the software. You'd never do this in manufacturing just because it's so costly and expensive with all the duplicate factories, but in software, because it's much cheaper and easier to create these manufacturing lines, we tend to do it. There's still a large amount of inefficiencies and waste in the system, but we have to deal with that. The next thing that you look at is when you're looking at this, if we want to get rid of the duplicate work associated with these branches, we need to minimize the time associated with how long does it take to get through this deployment pipeline. When I first started doing this, and I'd been personally going into organizations and figuring out how to change this, a lot of it was based on how long did it take to build, how long did it take to deploy, how long did it take to test, how long did it take to go through each of those processes. So I was very focused originally on the technology and the types of things doing it. What I realized as I worked with more and more organizations, even organizations that were years down their path to being agile at the team level, is I found that people really weren't moving the code from subsystems into QA or any of those different stages until they met stages more like development complete. And then when they met development complete, then they were ready to start doing the QA testing and move that way. And what they tended up doing with that is they build up large amounts of inventory. So you can see subsystem A would have 50,000 lines of code that really hadn't been integrated with subsystem 2 or subsystem 3. In manufacturing, they learned a long time ago that anytime you see inventory, you should see it as risk, and we should work to really minimize that inventory that we have in the system at all times. One of the biggest challenges I see with these large, tightly coupled systems is people build up large amounts of inventory to inspect in quality later. This is something that you would never do in manufacturing, but because of some unique characteristics of software, there's more incentives to batch this up and do the manual testing later. What we'll really do a deep dive on next month is really how to fundamentally change that by building in quality. We'll go into that in more depth. But inventory risk is a lot of what I see, and when you batch up this inventory, what it does is it reduces the time that it takes to go from code checking in to moving code through all these different environments. You know, QA can be 4 weeks out, maybe 7 weeks into production. The important part is understanding your manufacturing line, putting metrics on it, and figuring out where to do it. The other metric that we tend to look at is, you know, where the defects being found. In this case, we've got, you know, 60% of our defects being found in QA 4 weeks after developers have been writing code. If we want developers to get better, we can't expect them to be having that big of feedback and delay. For these types of organizations, typically the types of things we see are trying to change processes to enable the flow to go through more quickly. And to do that, we need to do that in such a way that we minimize inventory in the system, and we need to build in quality to do that, because if we're just letting code flow through the system as quick as possible, what we're going to end up is, you know, a really unstable QA environment or UAT environment. So we'll need the techniques that we'll discuss next month in terms of building in quality. But that is those are typically the biggest opportunities I see for improvements in large, tightly coupled systems. Then as you start to get this deployment pipeline stable in place, then we can start to look at the architectural changes. And if you've got a large, tightly coupled architecture like this, you can take a couple of different approaches. The most common one and the most talked about in the industry now is microservices, where you want to have a small microservice that has its data in it. It's got the application, it's got the UI, so that a very small group of people can independently develop, qualify, and deploy code on that, and you have a loosely coupled architecture. The challenge as you go into this is it's going to take a long time to take something like this that maybe 10 million lines of code and break it into independent microservices, and then you've got a large number of those to manage. From my perspective, there's two approaches. You can either do microservices to spin it out, or you can look at some of these interfaces here with service virtualization and the subsystems and say, are there some of the concepts from continuous delivery in terms of evolutionary database, versioning services between the different subsystems that would enable us to decouple those? So if I've got a large, very tightly coupled systems that has 300 people working on it, can I break it down into 3 subsystems that can be deployed independently that have 100 people each? And then can I break that down into 3 more that have 30 people each, and then 10 people? Is that an easier way to start breaking the coupling up, or is it microservices? And I think for you, you're going to have to look at your specific application, you're going to have to look at your specific challenge, and you're going to have to think about the types of things that you want to be breaking up first and what's going to be easiest for you. Microservices are probably where you need to be in the long term and where you need to be in the to make that work. But in the short term, can you get more benefits from, you know, not having to have 1,000 people work together, but have 3 teams of 300? Doing those types of things. Think about the problem that you're trying to solve. And with architectural changes with the tightly coupled systems, what we're really trying to do is we're trying to break these into much more manageable pieces. So this is probably your next best deployment pipeline to a loosely coupled system, because in this situation, I'm assuming that you own deployment, you can still do canary releases, you can still be doing A/B testing. There's a lot of applications that are out in the industry. There's a lot of work being done there where you don't really control the development and the deployment by the same organization. The classic application is custom off-the-shelf software that is developed by one company but deployed by clients in their environment. And in these situations, what we typically find is they need to make customizations. And these are applications like an ERP system, an MRP system, your ALM system, where there is a company that's centralized that develops and sells this software, and then it gets deployed on the customer side. For these organizations, the challenges are different. So if we're looking at optimizing flow and getting it to the customer, what we typically see as the biggest bottleneck to flow, and doing this more frequently, is getting the clients to deploy and update their software on a much more frequent basis. And if you look at the DORA research would say this is the most inefficient model from a DevOps perspective. These companies have slower mean time to repair. They are updating their software on a much less frequent basis. And this causes challenges both for the customers that are using the solutions and for the companies that are developing the software. For the customers that are developing the software, what it typically means is that because the customers don't want to upgrade to the new version, they force you to provide patches or on different branches of code that are very old. And so in this situation, not only are you not able to do monthly releases, but in this situation, you're frequently required to support branches that are several years old, where the customers need patches or different things. So from a developer's perspective, you deal with inefficiencies of all the duplicate work associated with supporting multiple branches. And as a user, you deal with the challenges of the difficulties of upgrading, the difficulties of modifying your customization, and the difficulties for getting solutions to your problems, because you've got to convince the provider to provide patches and solutions on very old code. For these types of organizations, the things you need to do is you really need to try to separate the customizations from the applications. If you're a company developing these type of applications, you want a very clean API between the customizations and the software you're providing. You want to make sure that that API is supported with rigorous automated testing to make sure that when you deliver more code, you know it'll work. You want to create processes and approaches that enable the customers to keep their customizations in a source code management tool, and you want to be able to apply those customizations automatically. In this situation, what you really want to be able to do is, if you're a client, what you want to be able to do is you want to be able to take the latest version of the applications, you want to automatically apply the customizations without any changes from the SCM, and then you want to run some automated testing. Ideally, it would be best if your provider is providing a very good framework for doing automated testing and the tools to make those customizations work. The reality is that's not naturally in place for a lot of organizations, and to make this model successful over the long run, the providers are going to need to be providing a very clean interface. They're going to need to make sure that those customizations can be captured in SCM, automatically applied, and they need to provide an automated framework. I know that's not in place for a lot of organizations, so if you're a customer using these types of things, there are, search the web, search with different user groups. There are people who've figured out, patches or fixes for doing those types of things. And if you are owning these pieces, being able to control your customizations and change your customizations and your application version differently at different times, and being able to do the automated testing is going to be key to being successful. That's much more important to you than figuring out how to go to loosely coupled. It's, you're not doing canary releases, you're not doing A/B testing. These are these different applications have different challenges. The other different type of application that's out there that has a different challenge is embedded solutions. This is, the LaserJet example that we had at HP. The automobile industry is going this way in a big way. Any of your IoT type of solutions, you're going to have software type code. You're typically going to have embedded firmware that's running custom hardware that runs on a emulator. And for these deployment pipelines, a developer can check in code, they can run some testing on a simulator, then that code can be added to code developed by firmware engineers that run on the emulator, and then eventually that code is tested and deployed on a product, and it goes through that way. If you're trying to become more efficient here, some of the biggest challenges you have is if you go further right on this deployment pipeline, the testing work, the defect fixing, all those things is duplicate, and it's hard to do automated testing on the end product. It's possible in some places, but it's just not as efficient. If you can move more of the testing and more of the processes to emulators, that's better because it's easy to automate. You can run those tests on a frequent basis, but ideally, some of those emulators are hard to get because you have limited custom hardware and they're stuff you have to manually set up. If you can move that testing more over to the simulator, where you have VMs that you can use to automatically run that testing. At HP, we had 4 racks of simulators where we were running automated testing on 10 million lines of code a day, and I think we had about 10,000 hours of automated testing that we were able to do on the simulator, and that fundamentally dramatically changed the productivity and efficiencies of how we were doing development. From an architectural standpoint for these types of things, you really need to be thinking about, is there an opportunity to move as much of the code out of emulator-based development to simulator-based development with your embedded software? To do that, you want a very clean hardware abstraction layer where we can take and make sure that any of the hardware-specific capabilities that exist in the firmware do not make it above that layer. It's similar to the difference between the customizations and the API layer between the applications that we talk about with customized off-the-shelf software. But in this situation, what we're really focusing on doing is trying to move as much of the code up into simulator-based development where it's much more efficiently, and make sure that we've got a clean interaction so that the changes in hardware and product don't impact the software capabilities. What we're trying to do with embedded software is we're trying to move as much testing further left on the deployment pipeline where there's less numbers of nodes to test on. And supply chain, they moved holding inventory to the left. And with software, what we're trying to do is move as much of the work as far left in the deployment pipeline before it gets duplicated across the system, and working through those things. In each of these cases, the types of architectural changes, the type of improvements, the type of process changes that you make to improve your efficiencies really depends on the applications. We have common principles of we're trying to improve flow, and we're trying to remove waste out of the system, and we're trying to build in quality, but really how you do that and the types of changes, just like in manufacturing, are very dependent on the applications. Hopefully I've convinced you through this that instead of just going out and copying the latest Agile practices or the latest DevOps practices and hoping your business improves, the first step is really taking the time to make your product visible, make your manufacturing process visible, so that you can fine-tune the practices that you will use for the specific applications. Loosely coupled are clearly the most efficient, and a lot of it's about releasing the team and getting out of the way. When you look at tightly coupled, it's coordination, quality. You've got different challenges with your custom off-the-shelf software. And when you get into embedded software, it's really the hardware variability, doing the product testing are very different. So each of these different applications has very different challenges, and if we just go off and blindly follow the practices that have proved successful for a loosely coupled system, doesn't necessarily mean that we're going to optimize the process for what we're trying to do. Having worked in a lot of different organizations, the very first place I start is by trying to make sure that I made the product and the process visible. Once we've understood this, then we'll start collecting metrics, analyzing each one, and we're going to apply engineering rigor to understanding the specific challenges associated with each architecture and each application. And different applications within your organization are having different challenges. And if we don't start by fixing the things that are slowing down the flow in your organization, you're not going to see the breakthroughs and improvements that you're hoping to see. Hopefully I've convinced you of that. I'm gonna hand it over to Jeff for a couple of minutes. Start thinking about your questions that you'd like to ask, because fairly quickly we're going to be moving into trying to create more of a dialogue on this, as opposed to just me trying to transfer information. Jeff?
That's right. Oh, it's good. And I mentioned before, how does Plutora fit into this? Gary, you've talked about making the work visible. That is one of the primary things that we at Plutora are interested in and help with. The essence is Plutora is a platform, as a cloud, as a SaaS-based solution. We integrate into the current tools that you have, pulling that data in, normalizing it so that you can look across your different deployment pipelines in a common method. That normalized data model then gives us the ability to do some really interesting things of normalizing the analytics, looking at every deployment pipeline and getting some common metrics of how fast is delivery, what's my cycle time, what's my lead time. We can even do the next step of converging the tool chains, of making work visible regardless of the tools that you're in, so that an incident on ServiceNow that is received by the help desk comes back in and relates to a bug that developers see in Jira that relates to a requirement or a defect that is found in HPLM. And as changes happen, we can help synchronize all those things together. That common data model and integration layer really unifies the tool chain that you have, and that is the foundation for creating visibility. Visibility creates efficiencies, and efficiencies then are augmented by the ability to do management orchestration on top of that. So we standardize the deployment pipelines. From a governance point of view, you can have phase gate kind of methodology on different types of releases, so that you just decide what kind of releases you're doing, and that's where we fit in. We can help manage the environments as they integrate in. It doesn't matter where you are in your journey, we help make that more efficient. And when you add the analytics and decision making on top of that, gives you the deep insights and predictive metrics for where you're going. You can then see your pipelines as they flow into the different stages of the environments, and have with it your overall audit and governance, your collaboration with your stakeholders, ultimately enabling you to look at a higher level and do a value stream mapping exercise to decide where you are today and what areas are the next step for improvement. And these things together will help you implement some of these architectural practices that you've just heard about today. The aggregate of these things is known as value stream management. And if you haven't seen it, next slide, Gary, there's a big push and it's been going on now we're coming up on a year, about value stream management. Go download this report off of the Plutora site or off of Forrester. We'll give it to you for free off of the Plutora site. Take a look into what does it mean to manage the value stream, because that's really what we're talking about, is to deliver software faster and better. So with that, we are ready to dive into questions. There is a questions box, and this is a great time to type in your questions. There's a bunch of questions that are there already that we'll dive into. We have to stop at about 5 minutes before the hour so we can have a couple of raffles going on. But let's see. Let's pick off some of these questions, and if you take a look at where the question box is, and feel free to type your questions, because this is a great time. So one of the questions is, how do you transform the architecture when you're dealing with what looks like a message bus or an information bus, IIB? Microservices best there. How should you look at transforming that in your architectures, and how does that fit?
It's when you have a messaging bus in there, the thing is thinking about how many people have to work together and where you can split it apart. That messaging bus can be a clear interface, but the messaging bus tends to tie you to a database, And one of the things that you see, even if you're trying to break it into 3 subsystems, part of that is you need to be able to pull your data apart. And some of the biggest challenges are, being able to have multiple people write to the data at the same time. A lot of the coupling that tends to happen in organizations is not as much on the messaging bus, because the messaging bus is trying to get to the data, but thinking more about how to take the data piece apart. And people that know me know that I'm not overly technical in terms of the detail, but what we've seen as we've gone into organizations is that challenge tends to be more at the data layer, and the model that you want to get to is more of Google Docs, where you can have multiple people writing and reading at the same time. I think makes your messaging bus between the different pieces easier. But whether you do it with microservices or macro services where you're trying to pull it apart, you are going to have to solve that data challenge where multiple people are needing similar data at the same time.
Very cool. You can go to the next slide, Gary. What modern architecture patterns do you recommend for data-intensive application stacks?
So I think I covered that a little bit on the last one. If I went in deeper, I'd probably be getting in technically over my head.
Understood. One of the things, there's a question on how can we transform the traditional IT in a company? And I think let me take a whack at that before you jump on that. The whole point of this webinar series is addressing exactly that question. There's a bunch of questions about, can you share this deck? Can you dive in? Absolutely. There is a whole book here, Engineering the Digital Transformation. And it's this is what we're talking about. Plutora as a company, this is our whole life, is helping companies transform their application delivery, providing visibility through it, and giving you the management and control that you still need while you do that. The approach of the book is, how do you engineer that? How do you change the architecture, and how do you change how you view what kind of metrics do you need? And the combination of these two things together is the answer to that question. It is not a short, one sentence answer of how do you actually do that. There's a lot more too. So Gary, why don't you take how can we transform the traditional IT in a company?
That, I think, is a huge challenge. You do these webinars and you have 30 minutes to kind of go through some slides and talk to it and not have the interactions. You don't have the workshops, you don't have those different pieces. So we try to give you snippets to get you interested in more of the information. A lot of the challenge is, how do you get there? And I try to write as short as I possibly can, because I know everybody's busy and doesn't have time to read it. But if you send your slides to this, slides@garygruver.info, just send me an email. You'll get reference to the slides from the first webinar and this webinar. You'll get an excerpt of the book that you can download and read. And I'd really encourage you to read the whole book. It's I write short. I write it so people can read it in a short period of time, but it's really answering that whole questions there. And one of the reasons I like this sort of partnership with Plutora is one of the biggest challenges I see is getting people motivated and understanding that they need to make these changes. A lot of the book and a lot of the engineering approaches is trying to make your products and your process visible, and then doing a very good job of making the waste associated with your processes visible so that you can motivate people to invest in making the changes to make it more efficient. There's a lot of great ideas. There's a lot of technology out there. What I see the hardest thing to do is get people to spend the time to fix these things and commit resources. Because what you're arguing is it worth sharpening the saw or cutting with the saw? And the business can always think up a great idea that can load up your organization to 150% of your capacity, but you're never going to get better if you don't take the time to sharpen the saw And a lot of what we do with this engineering approach and a lot of the tools that Plutora has, it enables you to pull the data out to make that waste visible, is you get people to understand the waste is there and get them to commit to making an investment to make the improvements so that you can be more efficient over time. And then the next challenge is once you've made a change, if you're not able to accurately advertise the improvements that you've made, you're going to have a hard time getting people to continue to make the investments and continue to make the momentum. So a lot of what I cover in there is the metrics that you should be looking at, not only to highlight your biggest sources of inefficiencies, but it's also to show that you've made progress and you've taken waste out of it. Because right now, all we can say is, yeah, we did Agile, or yeah, we did DevOps, and people are like, what'd you do for the business? I'm trying to take the conversation to the next level in this one in terms of how do we motivate everybody in the organization to broadly get engaged in continuous improvement of the product and the process. Because manufacturing with Lean Six Sigma got very good at motivating everybody in the organization to constantly be getting better. The challenge that you have in software is in manufacturing, you have one team that does the product development and then another team that optimizes the process. With software, we need to be optimizing the process and the product at the same time, because you're using the process to make the product better. So it's that tension between sharpening the saw and using the saw that's really critical, and making it visible of the opportunities to improve, and the fact that we've made improvements, I think, is key to getting organizations to change. And having worked with a bunch of different organizations, you'll see some that get way excited and they just lose momentum. I tend to spend a lot of time working with executives, because if they're excited about it, if they know how to measure it, if they know how to analyze it, and they can figure out how to coach their teams, that's critical to their success. And what I've tried to provide in this book is a systematic approach that enables the executives to get excited about it, be able to see the improvements, be able to help their teams, and be able to engage the broader organization in leading this transformation and making the changes. And I can't tell you how much passion I have about that, and can't tell you how much of it's frustrating to watch me see organizations struggle with that. A lot of it is, commitment, follow through.
That's so spot on. It's funny how with the billions that have been spent on development tooling, the most fundamental question most companies can't even answer, which is, are we really doing better than we were before? From an executive point of view, I only can empathize, the point of view of, they've heard things. They always said, well, agile, that's going to be the next thing. Lean, that's the next thing. Microservices, that's going to change the game. Well, at some point in time, there's a bit of burnout. Like, this is the next big thing that's going to just totally change the way our business is, but yet we can't answer that most fundamental question. That's precisely the reason we're doing this series together. You've got an excellent resource with Gary. Sign up, do a workshop. You can use Plutora to show the metrics of improvement. In fact, using Plutora, you can actually compete teams together, or compare teams, like which deployment pipelines are more efficient, which deployment pipelines are faster. You can show the metrics of the quality being produced, and what is the impact of sharpening the saw versus not. And then you can use that as the basis for making improvements wherever you need to. You compare lines of businesses and so forth. You can even compare architectures, because you'll be able to look at those kinds of things. There's value in putting these pieces together, because with Plutora, you've got the metrics of delivery, and with Gary, you've got the methodology to follow on how to improve. So if you're looking for help, you have the resources here. You get a hold of Plutora, get a hold of Gary. We'll work together with you to actually help you on this journey. That's why we're having this conversation. So don't do it alone. It's a hard one to have.
And key first step, and this is why this is our first deep dive, is you need to understand the problem you're trying to solve. You can't just go off and copy practices from Agile and DevOps and hope they solve the business. Analyze your process, analyze your applications, figure out what problem you're trying to solve, and use the approaches that are best designed to address your unique challenges. Because if you don't start showing some benefits and some real tangible results fairly soon, you're going to lose all the momentum that you've created in the organization, and your transformation is going to die out like most of them do.
Yep. It sort of reminds me of the Barclays talk at Enterprise Summit last year in Vegas, where the dev team was celebrating how agile and good they were doing, yet there was an 18-month cycle that was before feature intake, and then another 6-month cycle after the features were actually delivered to the operations team to actually get it into production. And make sure you're solving the right problems. That's where looking at methods like value stream mapping, where you look at the entire pipeline from ideation all the way into production, are really important, and solve the right problem.
Yeah,
Looks like, go
I
ahead.
can't tell you how many Agile organizations I go into that batch up huge amounts of inventory for inspection later and go into a hardening phase. If Deming found out that we were, batching up inventory for weeks or months at a time to inspect in quality later, he'd be rolling over in his grave. But it's the accepted norm, and people even have things called like hardening phase built into their product lifecycle.
Yep. Yes, they do. One question on branches. You seem to imply branches are bad, multiple branches are waste. So when to branch, when to not branch? How do I move forward with reducing my branches? How do I get there? Because it seems really hard given the kind of delivery I've got to do, and especially because I am still inspecting quality and afterwards.
Right. So there's two different types of branching. There's front-end branching, where you hold stuff off until you inspect in quality later. And then there's back-end branches, where you create multiple release branches because the flow doesn't go through quick enough for the business. To address the back-end branching, and you can't yet, branches is duplicate work, it's evil, it's all those other things, but you can't just get rid of it right away. If you're looking at the back-end branching, what you really need to be doing is optimizing that flow, shrinking it to where it meets the need of the business. So if you're an organization that does a lot of back-end branching because you can't deliver as fast as the business needs, as opposed to trying to figure out how to deliver more frequently, try to stay on the same delivery cadence, but reduce the cycle time and use that advantage of reduced cycle time to eliminate the branches. And that'll be a journey, and it'll take some time. There's a really good sort of story. Well, and I'll cover this in the next one. And then the other one is front-end branching. And the reason you don't do front-end branching, or the reason you do front-end branching is right exactly what you said, is you don't have the quality and you're not building it in, you're expecting it in. But test automation is getting to the point where we can start to do that. And you can't just say we're not going to branch and everybody's got to go to trunk if you haven't created the processes and approaches for building in quality. So next month, we're going to do a really deep dive into building in quality. And I fundamentally believe you've got to make that change, and you've got to move to that if you're really going to get a lot of the inefficiencies. And the problem that you have with back-end branches is it's a lot of duplicate work, especially if you have any manual testing left in your system. You're manually testing on all those different branches. The problem with front-end branches is you're delaying knowing about the interactions between codes that's off on different branches. So people will say, well, I don't have that problem because I update to main every day. But if you got a bunch of different people that are updating to main every day but not putting their stuff on main every day, you're not seeing the interactions between code that's being written, and so that feedback's delayed, and you tend up wasting time working on code that won't work with other code. So you don't want to back-end branch because of that, but to do that, you need to build in quality, which is a fundamental different approach. And there's the very first, well, Now, 2 webinars ago with Plutora, we did one with Ted Yule from Optum, where it really describes his journey of moving to building in quality. And I'd recommend going back and watching that one too, and we'll cover it in more detail next month too. But fundamentally, one of the biggest changes you need to make if you're going to modernize and change is building in quality. And you don't need full coverage to build in quality. You can start making progress now, but you do need some sort of quality gate in place before you start improving flow and eliminating the code that's left out on those branches that doesn't see the rest of the system.
Absolutely. My final comment is just don't go this journey alone. You've got help. Get a hold of me. I'll get you hooked up with right folks here. We'll connect up with Gary, get a hold of Gary. Help us help you in this journey. You can sharpen the saw. You can make changes. We can help you influence the executive level. We can help you through the process of delivering software faster. We really are in a world of disrupt or be disrupted. So don't feel like you're just stuck. We can help you. With that, Gary, this has been awesome. I guess we need to go to our drawing at this point.
Right. Yes. Yes, we have two big drawings. One is for three $50 Amazon gift cards. The other is 3 people to get a copy of the Engineering the Digital Transformation ebook that Gary wrote. So without further ado, let's go ahead and do our first drawing, which is for the gift cards. Our first winner is Lenore Adam. Congratulations, Lenore. Our second winner is Humberto Pina. Congratulations, Humberto. And our final winner of the $50 Amazon gift card is Tom Mars. Congratulations, Tom. Okay, so that's that. Let's go ahead and do the drawing now for the ebook. And the folks at Plutora will be following up with you with the winners after today's webinar to get the ebook over to you. The first winner is Fong Trin. Congratulations, Fong. Our second winner is Jennifer Eman. I think I pronounced that correctly. Congratulations, Jennifer. And our final winner is Dan Smith. Congratulations, Dan. So there we have it. Those are our 6 winners for today. Thank you to everybody who stuck around, and hopefully you were one of the winners. Such great information, this entire one. Yes, Gary.
If not, and you didn't win, you can go, buy an ebook pretty quick and easy at GaryGruver.com and link or send your information to the slides at GaryGruver.info, and I'll send you a link for a 10% discount on the book as part of the excerpt. So
awesome. All right.
Yep. Please treat this as the beginning of the conversation, not that was an interesting webinar. Nothing happens unless you do something.
All right, great. Well, speaking of doing something, I just want to remind the audience that the webinar has been recorded. So if you need to watch it again, or if you want to watch it again, you will have the opportunity to do so. We are going to be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the DevOps.com website. So you can always find it there. Just go to DevOps.com/webinars, look in the on-demand section, and it should be right there waiting for you. Also want to thank our speakers today, Gary Gruver and Jeff Keyes. Thank you to you both. Such great information that was translated in today's webinar. Good stuff. And as you said, Jeff, it's only part of the digital transformation puzzle. So good stuff. Thank you very much. Also want to remind the audience, also want to thank the audience for joining me today. And this is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.
Bye. Thank you.
Bye. Thanks for having us.